Hey everyone. So I'm making videos at home. Yes, that is a can of crushed tomatoes that this phone is sitting on, but I wanted you to see me work out some of these problems so that maybe when you work them, you can see where you go wrong, or if you had no clue how to do something, you can see me do it. That almost like class. Anyway, so this is the 3.5 and 3.6 practice sheet. And yes, this is kind of like review of what we were talking about before the break, but it's been a long time. So I wanted you to see this so that you would understand how to do some of them, especially the ones that look like these on the quiz. Okay, so this is number one, and it's asking you to remember a couple things. First of all, your trig derivatives, and second of all, what to do with 8 over x. Now you could use quotient rule, or you could change this to 8x to the negative 1 plus 4 secant of x. And then when you do the derivative, you can use the power rule. So 8 times negative 1 is negative 8. Subtract 1, you get x to the negative 2. Okay? And then 4 secant, since there's no x in front of this is not product rule or anything, you just throw the 4 in front of the derivative of secant, which is secant times tangent, or just secant tangent. All right, that's it. And then the last thing you need to do is just clean it up. That first term can look like this instead, negative 8 over x squared. And then this doesn't change, so you just rewrite it and you're all done. Put a little box around it. Lovely. All right, number 2. We're looking at things with t as the independent variable. And I don't like using t, but it stands for time, and time is very often the independent variable in physics problems, so I guess I'll just have to get over it. So here we have product rule, because we have t to the 5th, it's a letter, times a trig function. Over here, this is, again, can be rewritten as t to the 1/2 power. So like up here, making this monomial fraction look like this lets me use the power rule, whereas the square root thing written as 1/2 power lets me do the power rule as well. So here we go with the product rule. I don't know if you remember, some of you, I did a cross multiply thing before. Instead of that, it seems like some of you were confused by that, I'm going to just do it with a kind of using the formula. Thinking about the fact that if there are two things and I'm multiplying them and I'm finding the derivative, like I am here, then I take the derivative of the first, but not the derivative of this one. And then I say, not the derivative, derivative, right? So it switches. So for this first group, 5t to the 4th is the derivative, and then tangent, because not derivative, plus not derivative, t to the 5th, derivative, which is secant squared. And all of this comes from this. So I still have this left to go. Bring down the 1/2. Subtract 1, you get negative 1/2, right? Power rule. Okay. So there's nothing to do with either one of these two. They're not like terms. Not really going to change it. The only thing to do is deal with him, making him a little prettier. So let's rewrite all this junk. 5t to the 4th, tangent of t. T to the 5th, secant squared of t, minus, and then that negative power means he goes down, and the 1/2 means square root. So there you go. Yeah? Okie dokie, number 3. So this one is a little bit more complicated because there are 3 terms, and 2 of them are product rule. So we got t to the 5th cosine of t minus 14t sine of t minus 14 cosine of t. So here we have a product rule because there's a t in front of the trig function as it times. Here we have product rule, same reason, there's a t in front of the trig function. But here we do not. No t in front, so there's no product rule here. It's just find the derivative of cosine and slap the negative 14 in front of it. So let's do this one. I don't have to rewrite anything like the square root or the over x thing. So derivative, 5t to the fourth, not derivative, cosine. Not derivative, t to the fifth, don't forget your plus. And then derivative, which is negative sine of t. And I'm going to use parentheses because I get screwed up if I don't. I'll think 2 to the fifth minus sine of t, and that will be wrong. All right, all that's from the first one. On to the second one. Now this negative can cause problems, but if I think of this as one thing, negative 14t, and include the negative every time that first thing is included, it'll work itself out with the signs. So derivative, negative 14. Not derivative, sine of t. And then not derivative is negative 14t. And then derivative is cosine. Okay? And all that's from the second one. And then the last one, we have negative 14, and the derivative of cosine is negative sine. And once again, going to put that in parentheses so I don't screw up. Okay, so that's product rule, not product rule. And it creates 1, 2, 3, 4, 5 different terms. And I want to clean it up a little bit. Got 5t to the fourth cosine of t, nothing to do there. Plus, oh, nope, sorry. This minus can come out front, so it's really minus t to the fifth sine of t. That'll make it a little prettier. Then we have minus 14 sine of t, nothing to do there. Minus 14t cosine of t, nothing to do there. And then here I have two negatives making a positive 14 sine of t. All right. I see that this one and this one are like terms. They're both sines. One's negative 14, one's positive 14, so they cancel. Final answer, 5t to the fourth, don't go away. Cosine of t, talking to my computer. It tries to go to sleep on me while I'm looking at it. There you go. There's the answer for that, number 3. Okay. So number 4 and number 5 are second derivatives. And while they're not on the quiz, it's important that you understand that when you do a second derivative, you have to find the first derivative, like we did on these 3, but then you have to take the derivative of that. So with 5 sine of x, this is number 4 real quick. So y is 5 sine of x. You would have y prime is 5 cosine of x, because that's the derivative of sine. There's no x in front, so no product rule. And then the second derivative will just be the derivative of 5 cosine, which is 5 times negative sine. Negative. Forgot it. And then you can clean that up a little bit by throwing it out in front. Right? So that's second derivative. Not on the quiz, but you should know it. Zoop. Number 6. We're going to skip on over to 6. And that's asking you to find a tangent to a trig function's curve. So here's the function, y equal to cosine of x. It's a curve, and maybe you remember it does this little oscillation. And it's asking you to find the equation of a line, or find the tangent. So the tangent is the tangent line, I think is what they mean. If you look at the answers, I think it's y equal to mx plus b. So what we need to do is understand that derivative, I don't know if you remember this, equals slope. You have to remember that. So if we find the derivative of cosine, that'll give us negative sine, right? Hey, no. I don't know what you're doing, but you need to stop. Sorry, yelling at my cat. Yeah. Don't purr at me. Anyway, so here's the derivative, and they tell us that x is pi over 2. So basically, they want that plugged into the derivative. So that will give us slope. So negative sine of pi over 2. If you remember from trig, the sine of 90 degrees, same as pi over 2, nope, is 1. So this becomes negative 1. If the slope is negative 1, then we're going to use our point slope form. Y minus y1 equal to m times x minus x1. Yeah, okay. And here's my x1, pi over 2, the one they gave me. But where's my y1? My y1 comes from the original function, cosine of pi over 2. Just plugging in the x value to get the y value that goes with it. Well, the cosine of 90 is 0. So, dude, seriously? I don't know. All right. God. Working from home is super fun when you have a cat. All right. So plugging in 0 for y1, plugging in -1 for slope, plugging in pi over 2 for x, you get your tangent. All you got to do is distribute this -1, and you get slope-intercept form. -x plus pi over 2. Right? That's number 6. All right? Number 7, not on the quiz, but it's important that you know. Does the graph have any horizontal tangents? So y equal to the tangent of x minus x. We want to know horizontal tangents. Horizontal means that the slope is 0. That's a horizontal line, slope is 0. So basically, since the slope is the derivative, I need to know where the derivative is equal to 0. So let's find the derivative of this. The derivative of tangent is secant squared. Yeah. The derivative of x is 1. And then I'm going to set it equal to 0. Secant squared of x minus 1 equal to 0. Solving a trig equation is something from trig. Hopefully you did it. But if not, you just got to treat secant like it's the variable. Secant is the variable, not x so much at first. So add 1 over here. And you get secant squared is equal to 1. Take the square root of both sides, and you get the secant of x is equal to positive and -1. If you remember from equations, you need that plus minus whenever you take the square root of both sides. So where is the secant positive or -1? Well, I don't know about secant, but I do know that secant is 1 over cosine. So if you want to, you can think of this as 1 over cosine equal to positive or -1, and then flip it. So cosine equal to positive -1, because 1 flipped is still 1. Okay, so where is cosine positive or -1? That is at 0, that's at pi, and that's at 2 pi. And that's the amount, that's the thing they said at the beginning, is that x is in between 0 and 2 pi. That's what they gave you. This is what I found with the equation. So 0, pi, and 2 pi are all numbers where you have a horizontal tangent. And that is the answer. Woo! Like I said, I didn't put that on the quiz because it's a trig equation, and maybe you're not familiar with that anymore because it's been too long or because you're having problems with the whole isolation thing. I don't know. I'm trying to make it a little easier on you. All right. Number 8, we want to find the body's displacement and average velocity. So we have a position function, s, and it's 3t squared plus 2t plus 3, as long as t is in between 0 and 2. I put that little bubble because it's not really this. So to find the displacement, we need to figure out what s of 2 is and what s of 0 is, because where is it at 0, where is it at 2, and then subtract. So s of 2 would be whatever I get when I plug in 2 into the original equation. But Mr. Ernest, what happened to derivatives? We're just not doing derivatives right now, all right? Jeez, calm down. So when you work this out, you get 12 plus 4 plus 3, and that is equal to 19. Plugging in 0, we get 3, right? Because 0, 0, 0 plus 0 plus 3 is 3. So we just say 19 minus 3, and that is the displacement. Now they say it's in meters, so we're going to put a little m after that and circle it. Okay, now it says this is displacement. It wants the average velocity. Now, average velocity, if you remember, hopefully you remember, is slope formula. You know, the y2 minus y1 over x2 minus x1. So for us, we want, let me just write y2 minus y1 over x2 minus x1. And in our case, x is the time, so it's 0 and 2. And y's are the position. So that's translating the old slope formula from algebra into this particular type of problem when we have position and time. And so S of 2 is 19. S of 0 is 3. 2 minus 0 are the two times that I have. Okay? Don't let the 1 fool you. It's 0. 0 is T1, and 3 is S1. Okay, so last thing, just subtract. 19 minus 3 is 16. 2 minus 0 is 2, and that's 8. And that's meters per second if we're doing velocity. Average velocity. Okay? Very similar for number 9. Very, very similar. Except that the S formula is different. It's negative t to the third. It's plus 6t squared. And it's minus 6t. And our t values are 0 and 6. Little bubble. So I've got to find what S of 6 is. That's what I get when I plug in 6. So I get negative 6 cubed plus 6 times 6 squared minus 6 times 6. That's so many 6's. Negative 6 cubed plus 6 cubed. Remember, 2 plus 1. So that kind of cancels each other out. Since I don't have a calculator, that's very helpful for me. I do have a calculator, but I'm using it to do recordings. All right. S of 0 is what I get when I plug in 0. So 0 plus 0 plus 0 is 0. Right? Okay, so if I want displacement, I just subtract negative 36 minus 0, and there you go. Oh, meters. My old physics teacher would be mad at me if I didn't put that little m there. Average velocity, same as before. Average velocity is equal to S of 2, which is negative 36 minus 0, S of 1, right? S of 2, S of 1. And then T2, which is 6 minus T1, which is 0. So it's negative 36 over 6, which is negative 6 meters per second. And this tells me things, if you want to interpret this. So like up here, we can see that the whatever thing that's moving, the body, as they call it, moves 16 meters. And it doesn't say anything about its direction, but it kind of does, because it's positive. So it went from 3 on the number line to 19. So it's moved to the right. That's what displacement being positive means. It's moved to the right 16 meters. And its average velocity is 8 meters per second, which means it had a positive speed. It was moving it to the right. Here, the displacement is negative 36 meters, so it's like going left that much. And here, it's moving at this rate over that time. All right. So 10, 11, and 12 are all word problems. Yay. I'm sure you enjoy that. Give me a piece of paper, kitty. All right, got it. And you just have to kind of look and see what they're asking. So for number 10, I like to go to the last question, like immediately, whenever I see a word problem. And it says, when does the body change direction? Change direction means, direction. It means that the velocity goes from positive to negative. That's what it means to change direction. If it's a positive velocity, it's moving right. If it's a negative velocity, it's moving left. So if it's changing direction, that means it went from positive to negative or negative to positive. And we all know what's right in the center of the positive and the negative numbers. It's 0. So changing direction is asking is, where is the slope, the velocity, 0? So we got to find the slope. But they don't give us velocity, they give us position. And here it is. S is equal to t squared minus 6t plus 7 meters in seconds. And they also tell us that t is in between 0 and 6, kind of like the last problem. No, very much like the last problem, whatever. So when does it change direction in this time period, if at all? What we do is we find the derivative, because remember, velocity is derivative, right? Did I say that? Okay, I'm saying it now. The velocity is derivative. Before, when we did average velocity, we were using slope formula. But here, they don't want average velocity. They want to know if the velocity, the instantaneous velocity, is 0 and where. So we find the derivative, and that's velocity. And then we want to know where it's equal to 0. So we just set 2t minus 6 equal to 0 when we solve it. Oh, that's a linear equation. Look at that cute little baby. Add 6 on both sides. Here you go. And then divide by 2. There you go. And it's only one time. 3 seconds. And that is answering the question. When does, if ever, does the body change direction? It's at 3 seconds. We don't have to do anything else. So this is all about interpreting what they're saying, change direction, into when is the velocity equal to 0. Set the derivative equal to 0. Yeah? It makes sense to me. Number 11. Hopefully it makes sense to you, maybe if you have watched this a couple more times or watch another video on velocity and position. 11 gives us the position function of a ball dropping from the top of a building. I don't know why we're all so very interested in dropping balls off the top of buildings, but don't do it. It's dangerous. Well, maybe not now. People aren't outside as much. So we're dropping this ball, and it's in meters and seconds, and it asks you, the last question, how long does it take the ball to reach the ground? So the ground means that S equals 0, right? Because the ground is the bottom. That's where the position is 0. So it starts at 256 meters high, and then you drop it, and it'll eventually hit 0. So all we have to do, no derivative, just plug in 0 for S and solve. Yeah? Well, this is a quadratic, so I'm going to add 16t squared over here. Right? Do you guys understand that, what I'm doing? Like this? Huh? And then I'm going to divide by 16 on both sides because it goes nice and evenly, almost like they knew when they wrote this problem. It's 16. And then take the square root, and we get 4 seconds. We get positive and negative 4, I know, but we're not dealing with negative time, so... And does that answer the question? How long does it take for the ball to reach the ground? 4 seconds. Sure does. But there's a second question. What is the ball's velocity at this time? So velocity, remember, is the derivative. This is part 2. So the derivative of this guy, 256, goes to 0. And then you bring down the 2, multiply it, and you get negative 32 t to the 1. Okay, well, let's find the velocity. It's negative 32 times the time, 4 seconds, when it hits the ground. And that is negative 128, right? Meters per second. That's how fast it's going when it hits the ground. Now, this is without, what is it, air? It's in a vacuum. I don't know why we like to do things in a vacuum. I guess it's because it's easier mathematically. But that answers both of those questions in number 11. Number 12, we're throwing a rock upward on an airless planet. So once again, in a vacuum, this planet has no air. You know, just in case we're ever on a planet with no air, we can know some things. So we got this is the position function, and it asks how high does the rock go? So it starts at 0. S of 0 still means the ground. If it's asking for how high, then we have to ask the question, what's going on at the top of its path? And if it's going all the way up, to this certain point and then it starts coming back down, then right here, the velocity is 0. It goes from, I guess, a positive velocity, if up is positive, to a negative velocity, where down is negative. So, once again, where it changes direction means that the velocity, the derivative, is 0. That's what they want to know. So what's the derivative? We got 120, t becomes 120. And then we got 10 times 2 is 20, and then t to the first. Oh, look at that. It's a nice linear equation again. Oh, gee. Thanks, Mr. Ernest. This is so nice to do. You're right. You're welcome. You're welcome. I'm going to add 20t to both sides, because I know that's what I'm supposed to do. 20t equal 120, divide by 20, and I get 6 seconds. Now that's how long it takes. That's how long it takes for it to hit the highest point. But that's not the first question. That was the second question. It says, how long does it take the rock to reach its highest point? Well, there's part 2. B. And up here, this is A, and this is B. But what I want to know is how high. So I know the time it takes to get to a certain height, but that height can be found with this formula. So S equal to 120, but instead of t, I'm going to plug in as 6. Time it takes to get to the highest point. And then 6 squared over here times 10. That will give me 720 minus 36 times 10 is 360. And that gives me 360 meters. That's the highest point. I think that's it. Yes, it is. Okay. So be on the lookout for 3.7. That one is probably a little bit more helpful than this one, since we probably did this one before the break. But hopefully this helps you in case you were stuck with it. Thanks.